Welcome to Bashir Electric once more. So let's look at this sequential control circuit, then you can tell yourself where to apply it from. So I'll have here my power supply as usual, then I'll have my conducting cables as alive, then I'll have the neutral. This is not complete here. Then I'll have protection earth. So I'm going to have 3 direct online motors. I'm going to have my circuit breakers and 3. I'm going to have my contactors and 3. I'm going to have my overloads and 3, and I'm going to have my motors and 3. So there we go. Now let's do our connections. We shall get here our connecting cables. Choose this one. They have that one there. Ones I take to the contactor, I take to the overload, then I take to the motor. Like that, our power circuit is done. Only let's do the naming. This one is S1 circuit breaker 1, this one is circuit breaker 2, this one is circuit breaker. S means switch 3. Then this one is KM1, this one KM2, cancel. This one was wrong. KM2, okay. Then this one is KM3. Okay, then this one is thermal overload. F stands for fuse. Let's just use that one, F1. When we add protection to our motors, shall have something of the sort. After the power line, let's do the control. I'm going to get here my control breaker, that's 2-pole. Then I'm going to have an emergency switch. Before the emergency switch, normally closed of the overloads, and here we use all the 3. This one shall represent all the overloads, but you have to use each. Then this one, I'm going to use it as a stop. Then I'm going to get a normally open to act as a start. Then this start is going to power the main contactor, which is a coil, that is KM1. So it's going to power here KM1, but it's going to pass through the normally closed of timer 4. What is timer 4? Yeah, we are going to have 4 timers in this circuit. So let's go. As well as it's going to power the first timer, which is around here, connection time. So when we do the cabling a bit, we shall have, get here, let me use this one as my control. I'll get from the nearest phase to act as a live, then through the overloads, then through the stop. This one is not the stop, that one is emergency. Then start. Then from there I'm going to power the contactor 1 through the normally closed of timer 4. This one can call it timer 44. Then this one is KM1 contactor 1. Then this one is timer 1 coil T1. I think. Then contactor 1 is going to self hold itself. How? Through a normally open contact here, around there. So this one is a contact of KM1. There we go. This switch, I'm going to name it start. As I told you, this one is just emergency, not a stop. It is the emergency. So this one is going to power this one as well. But it is going to pass through the normally timer 1 to be powered is going to pass through the normally closed of a certain component. I shall tell you that component. So when I draw my cable, just like that, there we go. Then this one shall power the timer. Now what is this contact here? This is for KM2. KM2, as KM2 is going to be powered through the normally open of the timer. So I'm going to have a coil here, and I'm going to name it KM2. That's the second contactor. Then it's going to be powered. So what I've forgotten now, contactor 2, it is going to self hold itself. Yes, so this is KM2 as well. Because I'm doing this, I'm designing in a way that once timer 1 powers contactor 2, for it has to go off and leaves contactor 2 alone. So contactor 2 has to self hold itself, and that is the logic. So from there, it is going to self hold itself, but it is going also to power timer 2 at the same time. So I'm going to get this coil. So this one, if I name it, it is timer 2 T2, and T2 is going to be powered by, it's going to pass through the normally open of, it's going to pass through the normally open of K2. So this one is KM2. Are you there? And it is going to pass through the normally closed of KM3. Why? Because once it powers KM3, for it goes off and it leaves KM3 with its own problems. Like that. So now we are going to have KM3. We are going to name it KM3, and it is going to pass through the normally open of the timer. Then after, it is going to self hold also itself. So this one is timer what? Timer 2 T2, and this one is KM3. Now let me first do this wiring, then I explain something. That one is not reaching, like that. So actually these timer contacts, the ones named T4, T2 and T1, they don't work. I'm going to use these ones. Let me replace them with these timed contacts here. So I'm going to replace, don't quarrel. I've replaced, let me zoom for you and you see. Hope you can now see. This is normally closed of timer 4, normally closed of contactor 2 to timer 1, normally closed of timer 1, normally open of contactor 2, which is this very one, normally open of contactor 2 to power timer, 2. We have timer 1, timer 2. Contact starts KM1, KM2, KM3. This is normally open of timer 2. Here contactor 3 self holds itself. So for this one, I'm going to first do, let's give it the neutral. Now when I get our neutral from here, it is around here to the breaker, and from the breaker I'm going to bypass it a bit this way behind. So this one is the starting sequence, I think is done. But allow me extend these components a bit up because we need more contacts. I have not made any change. I've just extended these contacts a bit up so that we can add more contacts down here. So here down I'm going to add a normally closed. I'm going to add here a normally closed, and also around here I'm going to add a normally closed. Now this one is a normally closed of timer, it will be timer 3, I think here. Then this one will be a normally closed of K, it is going to be a relay. So this is the connection, the normally closed for a timer to a serious engineer. That is that. Let me zoom back. Now we are going to our stopping sequence. You look what I'm going to do. I'm going to get a normally open. It's the one which is going to act as a stop. A normally open push button. This one. I'm going to put it. Let me put it around here. Then I'm going to name it stop. But it is a normally open stop. Then I'm going to have a relay around somewhere. I see. Then I'm going to have now my cable from here. I power this normally open. Then from this normally open, I'm going to come and power my relay. But I'm going to power my relay through the normally open of contactor 1. That means contactor 1 must first start before this relay operates. So I'm going to have here normally open of contactor 1. This is contactor 1, KM1. Don't forget. What's up? So I'm going now to complete that cable of mine, so that I can also feed my PC. It is correctly. So I'm going to power. It's going to power through the normally. Yes, I've powered from power through the stop. Stop is normally open here. Then through the normally open of contactor 1, then to the relay. So the relay, this K relay is going to self hold itself from somewhere here like that. So this one here is a joint. Now this software is fake, it may not recognize that one. So it's going to power timer 3 at the same time. So I'm going to get here timer 3 coil and put it around there. So this one is timer 3 T3. Okay, and T3 is going just to get there immediately from this friend to T3. Are we there? Then I'm going to have timer 4 around here. Then let's name it T4. Okay, then timer 4 is going to get from normally open of timer 3, which is around here. normally open of timer 3. I can just get from this self-held power. So if I name it, this one is T3. I think that is it. So also when I give that thing there, this thing here, a neutral, when we do a modification of our circuit, we are going to add here a normally closed of our relay. So I add the cabling here like that. So that is our sequential control circuit. We have 3 contactors, each contactor controlling one motor just direct online. Then we have 4 timers, timer 1, timer 2, timer 3, timer 4. We have start push button is a normally open, stop push button is a normally open, and we have our emergency normally closed. Then we have our overload representing all the overloads. So let me zoom a bit back, let me extend a bit. I want us to do this simulation when we are all clear and we see what it does. So when I say here play, then I switch on here main breaker for motor 1, main breaker for motor 2, main breaker for motor 3. Then here we are going to switch on our control breaker. So normal starting, we press a start. Are you seeing? We start motor 1 starts immediately. After some time motor 2. After some time motor 3. Are you seeing? As I told you, timer 1 and timer 2, once each timer switches on the respective contactor for it, it goes off. So what is the normal stopping? When you press a stop button, motor 3 goes off. After some time motor 2 goes off. After some time the whole system, all motors go off and the whole control go off. So that is what we call sequential control or order of operation. Then how does an emergency stop work? In case when all the motors are already in running mode, like you are seeing right now, then you press here emergency stop. You see, emergency, all motors stop at once when there is no sequence. Thanks for watching. That is how we do this. This circuit is applied in conveyor control. It is also applied in connection of slip ring motors when you are connecting to resistance boxes, and many more other applications. See you when you see me in the next circuits.